In this presentation, we'll discuss distributed database management systems. In a distributed database system, a database is composed of several parts known as database fragments. These fragments are located at different sites and can be replicated among various sites. Each database fragment is managed by its local database process. Distributed processing is not the same as distributed data, although the two concepts are often related. As shown here, it is possible to use centralized data in which the data is stored in a single location with distributed processing in which the processing has been distributed among many locations. The distributed DBMS must include at least these components: workstations or nodes that form the network system, network hardware and software components that reside in each workstation or node, communications media that carry the data from one node to another, the transaction processor, TP, which is the software component found in each computer or device that requests data, the data processor, or DP, which is a software component residing on each computer or device that stores and retrieves data located at that site. The data processor is also known as the data manager, or DM. While it is possible to have various combinations of distributed versus centralized processing and data, it is not possible to have distributed data without distributed processing. If the data are distributed, then at least some of the data processing functions of the DBMS must be distributed to each data site to manage the data at that location. In the case of single-site processing, single-site data, the functions of the transaction processor and the data processor are embedded within the DBMS on the host computer. The DBMS usually runs under a time-sharing, multitasking operating system, which allows several processes to run concurrently on a host computer accessing a single DP. All data storage and data processing are handled by a single host computer. In multi-site processing, single-site data distribution, note that the TP on each workstation acts only as a redirector to route all network data requests to the file server. The end user sees the file server as just another hard disk. The end user must make a direct reference to the file server to access remote data. All data selection, search, and update functions take place at the workstation, thus requiring that entire files travel through the network for processing at the workstation. Such a requirement increases network traffic, slows response time, and increases communication costs. Depending on the level of support for various types of databases, DBMS are classified as either homogeneous or heterogeneous. Homogeneous DBMSs integrate multiple instances of the same DBMS over a network. For example, multiple instances of Oracle 11g running on different platforms. In contrast, heterogeneous DBMS integrate different types of DBMSs over a network, but all support the same data model. A fully heterogeneous DBMS will support different DBMS, each one supporting a different data model running under different computer systems. This concludes this presentation.